Welcome to Maths with EJD. In this video, we'll talk about regression and particularly focusing on simple linear regression. Okay, let's start this way. Okay, let me go with this. All right, let's talk about regression itself before we go to simple linear regression. Uh, okay, so regression analysis regression analysis is a powerful statistical method used to examine the relationship between two or more variables. So if you want to see what's going on between two or more variables, regression is one way to see that. All right. Then let's talk about, okay, well, uh, since I'm going to be specific with simple linear regression, let's go to that next. But before that, if you have not subscribed to this channel, be sure to do that and hit the notification bell so you can always get alerted each time a new video is released. So let's go for simple linear regression. Simple linear regression. So in simple linear regression, of course, there's simple regression, simple linear regression, and there's also multiple regression that we're going to see later. So in simple linear regression, the relationship between two variables is modeled with a straight line. It's modeled with a straight line. That's why it's called simple linear regression. So the goal in this case is to predict the dependent variable y based on the independent variable x. Okay. The general formula of the linear regression model is y equals beta naught plus beta 1x plus epsilon. And we need to know what each component stands for. So this y is actually the dependent variable, that's your y. And then something like the one you are predicting. The dependent variable is what you are predicting. So that is what you are predicting. That's a dependent variable. Then the next thing is your x. This x is actually the independent variable. It is the independent variable. Independent variable, or you can call that the one you are using to predict the one you are using to predict. That's the independent variable to predict. Okay. Of course, this is in this cage. Then we have, okay, the dependent variable can be something like maybe exam score, while the independent variable can be like hours studied, like that's the same example we're using all along. Then beta naught is the intercept. So this is the intercept. This is the intercept, which represents it is the intercept which represents the value of y, the value of y when x is 0. So that's more like the base so you can't go below that b naught. It's like the basic thing, even when nothing is happening. Then we have the slope too. We have b1. Go this way. Okay, let's take that b1 up. B1 is actually the slope. So b1 is the slope, which indicates the change in y, the change in y for 1 unit increase in x, for 1 unit increase in x. Of course, that sounds like dy dx. So if you differentiate that expression, you are going to get b1. So that is if x increases by if so if x increases by 1 unit, right? So b1 is going to amplify it, and that will affect the value of y. So that is the slope. Slope, which indicates the change in y for 1 unit increase in x. And that is why dy dx is actually that b1. So then we have the error lastly. We have the error. Of course, since you are fitting something to an equation, there's bound to be some kind of error, no matter how little. So this is the error term. Epsilon is the error term representing the difference between the observed and predicted values. The observed and predicted values. Okay, so y equals b naught plus b1 x plus epsilon. Okay, so having said all that, can we talk about key formulas in linear regression? Key formulas. Of course, that's the general formula, right? Key formulas in linear regression. How do we obtain each component? Key formulas in linear regression. So let's say let's talk about the slope. Let's talk about the slope, B1. How do you get the slope? So the slope of the regression line, can be calculated using the following formula. So the formula again here for beta 1 is n summation xy minus summation x summation y divided by n summation x squared minus summation x all squared. Does it look like what you have seen before? Do you remember? This looks so much like the equation, the formula for the Pearson correlation coefficient, except for the denominator where this would have been square root of what you have there multiplied by the component for y. So that's the only difference. So here now we don't have square roots and we don't have n summation y squared minus summation y all squared. That's the only difference. So this is how to get B1, and we are going to demonstrate how that works very soon. Okay. N, of course, as usual, is the number of data points. Number of data points. So that's the pair of x and y that you have. Then x and y are individual data points. So x and y are individual data points of the two variables. Let me just put it that way. The two variables. So it looks so much like the Pearson correlation coefficient, except that we don't, the denominator is different. It just somehow different. Okay, that's how to get beta 1, and that's for the slope. Let's talk about the intercept. How do we get beta naught? So let's talk about the intercept, beta naught, intercept, beta naught. So the intercept is the point where the regression line crosses the y-axis, and it is calculated as, so beta naught equals y bar minus beta 1. Okay, based on what we have up there. Okay, I mean, let's leave it the way it is. So beta naught is y bar minus beta 1 x bar, like that. So we know, that okay, it's the cage for that. Then y bar and x bar, they are both means now. They are means of the variables. They are means of the variables. Okay. Of course, we already know what beta 1 is. So the beta 1 you would have got already can now come here together with the y bar and x bar. So the means of x and y in that case. Then the other part is the predicted value of y. So we talk about the predicted value of y. Predicted value of y, which we can call y cap. So once we have the slope, and intercept, those are the two things we need, because it's usually y equals beta naught plus beta 1 x plus epsilon. So once we have beta naught and beta 1, the equation is as good as derived. So once we have the slope and intercept, the regression equation allows us to predict the value of y for any value of x. Okay, so we can have y cap equals beta naught plus b1 x. That's for prediction now. So this gives us the predicted value of y based on the input value of x. Then we can also talk about the residuals. So residuals. So that should be the error part. So the residual E of I is the difference. Okay, since we already have that as the error term up there, so it's better I use the same thing. So the residual epsilon, as we saw up there, is the difference. It's the difference. The residual or error term, I think that's what it should be. The residual or error term, epsilon, is the difference between the observed value, y, and the predicted value, which is y cap, so that the error term is y minus y cap. Okay, y minus y cap. So residuals measure how far off the predictions are from the actual data points. So the goal of linear regression is to minimize the sum of the squared residuals. Known as the sum, let me put that in my classic way, the sum of squared errors. Sum of squared errors, just like the residuals are errors. Sum of squared errors, that is SSE. Okay, so that lays the foundation for simple linear regression. It's time to go for an example. So let's talk about an example. Consider the case consider the case below for this hour studied and exam score has been coming with us since the very beginning of this course. So consider the case below for hours studied X and exam score Y. So now we have hours studied X together with exam score Y. So that's study for 1 hour, that's 55. If you study for 2 hours, you get 60. Study for 3 hours, you get 65. You study for 4 hours, you get 70. You study for 5 hours, you get 75. You study for 6 hours, you get 80. You study for 7 hours, you get 85. You study for 8 hours, you get 90. Okay, that's the information we have. So we want to get a linear regression, we want to get a line, an equation to put this together. So we can now use that to predict a student's score based on this information. Okay, so hour studied and exam score. And the way to go is, since we are looking for the regression, right, it means we need to compute beta 1, beta naught, and all that. So uh we can say something like the data fit the data to a simple linear regression, something like that. Fits the data to a simple linear regression. So again, let's recall, let's recall okay, let's recall the that y is equal to beta naught plus beta 1 x plus the error term, and that so okay, let's just go this way. To find beta 1 is usually the easiest to find. It's the first to find because we need it to find the others, right? So to find beta 1, we know that beta 1 is very close to what we did for a Pearson correlation coefficient. So we have summation x. Okay, let me be consistent. Summation xy minus summation x summation y all over n summation x squared minus summation x all squared. Okay, so we need all of this. So what do we do? Okay, let's get the table again with only the variable. So we have x, y. From that again, we need x, y. We need summation of x, summation of y. Then we need x squared, and we need x and y together, x multiplied by y. I think these are the things we need. We need x, y, this is it. We need x, we can get from here, summation. We need y, we need summation of x squared. Yeah. So we are good to go. All right, so we have 1, 2, 3, 4, 5, 6, 7, and 8. So that 1, the score is 55, 2, 60, 3, 65, 4, 70, 5, 75, 6, 80, 7, 85, and 8 is 90. Okay, so we need x squared. X squared will just be the square of 1 here. That's 1 times 1, 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. And then we need xy. That's multiply. So that's multiply this by this now. So 1 times 55 is 55. 1 times 55 is 55. 2 times 60 is 120. 3 times 65, 3 times 15, that's 5. Remainder 1, 18. That's 195. 4 times 70 is 280. 5 times 75. 5 times 75 should be 5 times 5, 25 will hold 2. 5 times 7 is 35. That's 375. 6 times 80 is 480. 7 times 85. 7 times 5 is 35. Hold 3. 7 times 8 is 56 plus 3. That's 595. 8 times 90 is 720. So we need all this now. We need summation of x. The summation of x is okay. Okay, I really have to do this to be sure everything is in order. So summation of x, right? That's okay. We're adding 1 to 8. So add from 1 to 8 is just 8 times 9. 8 times 9 is 72. 72 divided by 2, that's 36 altogether. Then we have summation of y. The summation of y, we have 55, 55 plus 60 plus 65 plus 70 plus 75 plus 75 plus 80 plus 85, then plus 90. That's 55, 60, 65, 70, 75, 80, 85, 90. So all of that will be 580, 580, 580. Then we go for the next one. We need summation of x squared. So that will be 1 plus 4, 5. 5 plus 9 is 14. 14 plus 16 is 30. 30 plus 25 is 55. So 55 plus 36. 55 plus 36 plus 55 plus 36 plus 49 plus 64. That is 204. 204. And lastly, we need summation of xy. So that will be 55 plus 120 plus 195 plus 280 plus 375 plus 480 plus 595 plus 720. That is 2820. 2820. So with this now we can easily get B1. So we know that B1 is equal to N. So okay, we need N, right? N is the number of data points we have. So that's simply 8. That's 1, 2, 3, 4, 5, 6, 7, 8. So N is 8 simply. So we can fix everything now. So B1 is N, which is 8. So we have 8 times summation xy, that is 2820, minus summation x, that is 36, times summation y, that's 580, divided by summation x squared, which is 204. 204 minus summation x all squared, that is 36 squared. That's 36 squared. Okay, we have 204 multiplied by n. N is 8. So we have 8 multiplied by 204. So that beta 1 is now 8 times 2820. 8 times 2820. 2820. That is 22560 minus 36 times 580. 36 times 580. That is 20880 divided by 8 times 204. 8 times 204 is 1632 minus 36 squared. 36 times 36. That is 1296. 1296. So that beta 1 is equal to 22560. 22560 minus 20880. So that is 1680. 1680 divided by 1632 minus 1296. That is 336. 336. So that'll be approximately 1680 divided by 336. 336. And that is equal to, interestingly, that is 5. Okay. In fact, it's not no approximation, it's just 5. Lovely. That's 5. Okay. So we have B1. This one is to find B1, right? The next thing is to find, we want to find B0. To find B0, right? B0 is equal to what's the formula again? B naught is y bar minus beta 1 x bar. Thankfully, we've got beta 1 now. So we just need y bar and x bar. And we know already that y bar is equal to summation of y. We can do this, summation of y over n. So summation of y is 580. So 580 divided by 8. So 580 divided by 8. Let's just do that straight. 580 divided by 8. 580 divided by 8. That's 72.5. 72.5. That's 50 divided by 8. Then x bar is summation x over n. And summation x is 36. So that'll be 36 divided by 8 also. So 36 divided by 8. That is 4.5. 4.5. Okay. So with that in place, don't forget B1 is 5 already, so we can go now. So we can say therefore B naught is equal to y bar is 72.5 minus B1. B1 is 5. That's 5 times x bar, which is 4.5. So that B naught now is equal to 72.5 minus, that's 45 divided by 2. That is 22.5, I believe. 22.5, yeah. 22.5. And B naught is 72.5 minus 22.5, which is simply 50. Lovely. So with that now, we have our equation. So once we get B naught and B1, we can go ahead. So let's go now. We can now say, therefore, the regression equation is y, of course, equals B naught plus B1 x. So that is y. B naught, we have B naught to be 50 plus B1, which is 5 x. So this is our regression equation. Lovely, lovely, lovely. But of course, don't forget, there's an error term. But here you don't worry about the error term until you make a prediction. Okay? Until you make a prediction. So this is our regression equation. So we can go ahead now and make a prediction with this, so we can also get to talk about the error term. So let me go on and talk about making predictions. Making predictions. Okay. So using the regression equation, we can predict the exam score for any number of hours. So it's more like you now have an equation to say, as far as these students are concerned, we can predict with some level of certainty that this is what they are going to score based on the hours they spent studying. So using the regression equation, we can predict the exam score for any number of hours studied. So for example, if a student studies for 5 hours, then we can have y bar equals, as usual, beta naught plus beta 1 x plus plus epsilon. So that means that we have y bar equals, so now x, so 5 hours simply means that x is equal to 5, right? So, and we already have beta naught and all that. So beta naught again is 50 plus 5x plus epsilon. This is 50, this is 5x plus epsilon. So studying for 5 hours now means x is 5. So we have y bar equals 50 plus 5 times 5 plus epsilon, so that we have y bar equals, okay, I guess I should, let's rest the epsilon first when we want to predict, so we can always do that later. So we have here 50, yeah, 50 plus 25, and y bar is equal to 75. Interestingly, we can check this because it still falls within the range of the table. So somebody who studied for 5 hours, what was the score? Interesting. So if you study for 5 hours, you get 75. So you can see the model is perfect, right? Like it's perfect. So we can also already be sure that the error is going to be 0. But of course, to be very sure, let's do that. Uh okay, we can just say therefore a student who studies, student who studies for 5 hours is predicted to score approximately, I mean, to score, it's not even approximate now, to score 75, basically. Okay. So let's talk about computing the error. Computing the error. So we know already that y is equal to beta naught plus beta 1 x plus error. And we know that now y is, from what we did up there, normal y from the data is 75. Y bar, the predicted y, is also 75. So, and we know that error is simply, what's the formula again? I think we talked about that way before now. Yeah, that's y minus y cap, not bar, y minus y cap. So this is y minus y cap. So this is the observed value. That's the value in the table. So this is the observed value, while this is the predicted value. So now the error term is actually 75 minus 75. So the error in this place is 0. That is, we have a perfect linear regression. That may not always be the case because, this data is at best, this data is made up. So when you have real data, you're going to actually have you will most likely have a specific error, that goes with the data. So, but this has helped us to actually, establish the case. Interestingly, right, you can write the equation in terms of what you're talking about. So once you get this right, you can actually say this is the same thing as y is the score, right? Exam score. So we have exam score and hours studied. So we can have so this is like, you can say this is simply exam score. You can say this is exam score equals 50 plus 5 multiplied by the hours studied. You can do that too. Okay. So to make it make more sense. So what it simply means is that even if the student does not study at all, that means the hour studied is 0. So if you put 0 here, you get 5 times 0, and that's 0. So it means without studying, the student would just automatically get 50 marks without studying. But every extra hour they study, the score is increased by 5. That's what the slope is about. So the intercept is about the fact that even if you do, when the hour studied is 0, that's what you're going to get. Well, the slope says that every additional hour you study, your score increases by 5, like that. So that's what this has been. So it's such an interesting thing too. So it's so when we talk about equations, they're basically models too, right? So this is like a model that we can use to predict a score, the score a student is going to get, based on the hour study. So, and you can do that with any two variables. We're going to talk about multiple regression in the future, but the video after this, I'm going to write a Python code to show how you can implement regression, how you can implement this simple linear regression. So I'll show a Python code to that effect to get exactly what we have got here. Because if you have to deal with very large data, doing it manually may not make sense. Okay. So let's go for that. If you have not subscribed to this channel, be sure to do that and hit the notification bell so you can always get notified each time a new video is released. Then don't forget to comment if you want me to teach a topic or solve a problem. If the time is right, or when the time is right, I can always attend to this. And of course, hit the like and share so that more and more people can get to learn these very important lessons. Till I see you again, have a nice time. Bye.